So our fourth chapter is section of solids and development of surfaces. As like the projection of solids, section of solids also follow the same procedure of projection of solids. So here the solid is subjected to sectioning by cutting plane. After sectioning, how it will be to the observer in front view and top view that has to be projected. After sectioning, the projected front and top views are called as sectioned front view and top view. So let's see how to approach this type of problems. So here there is a problem. A square pyramid of base side 30 mm and axis length 60 mm is resting on HP on its base with a side of base inclined at 30 degree to vertical plane. Then it is cut by a plane inclined at 40 degree to HP and perpendicular to VP and passes through the axis at a distance 25 mm from apex. Draw its front view, section and top view, and true shape of the section. Okay, so this is the question. So here the given object is square pyramid, and that the square pyramid object is subjected to sectioning. After sectioning, we have to draw front and top view. That is the question we have got. So here square pyramid, and it is a pyramid. So square pyramid means it has one base, one apex. The shape of the base is in square. So four base sides, four slanting edges, one apex, four base corner. These are all the four triangular faces. These are all the maximum parameters in a square pyramid. So here the dimension of the square pyramid given in this problem is base side is 30 mm and the axis length is 60 mm. These are the dimensions. This square pyramid is resting in HP on its base. So it has one base. That base is resting in horizontal plane. How it is resting means it has four sides in the base. These are four base sides. One of the base side is inclined to VP at a 30 degree. In such a way, base of the square pyramid resting in horizontal plane. Then that square pyramid is sectioned by cutting plane. The cutting plane is perpendicular to VP and inclined to HP. How much inclination means 40 degree inclination to HP. So here cutting plane is inclined to HP. So they have to represent that cutting plane details in the front view. Where the cutting plane we have to represent means the cutting plane meets the axis at a distance of 25 mm from the apex. So on the axis, by taking 25 mm distance, we have to represent the cutting plane line. After that, we have to do it from the top and the two shaking position. So for this, uh, before sectioning, we have to draw both the views. That is the top view and the front view. So which way we have to draw first means? So here the base is resting in horizontal plane. There is axis perpendicular. Other time, axis of the solid is perpendicular to and parallel to VP. And which portion I will be getting true shape of the base means in the top view. So when I see from the top of the object, when the base is resting in horizontal plane, I can able to see the true shape of the base. So first I have to draw the top view. In the top view, I can able to get the true shape of the base. How to draw a top view? First, we have to draw a reference line, XY line. To that line, below XY, horizontal plane, above XY, vertical plane. On the horizontal plane, we can able to see the vertical plane inclinations. Object parameters inclined to VP conditions visible in the horizontal plane. So for now to this XY line, 30 degree inclination, we have to draw one line. On that line, we have to represent one side of the square. So here the square base is 30 mm. So on the 30 degree inclination line, we have to represent 30 mm line. Then to that side perpendicular again we have to draw 30 mm line, 30 mm line, then close that. So now we have done square base. And then it is a pyramid. So when I see from the top, along the base, four slanting edges, apex, everything visible before sectioning. So that is also you have to draw that. How to represent that as slanting edges means just diagonally connect that base corners. Then these diagonal lines are intersecting. That is our apex point. Then from the apex, a line goes up to bottom base corner that representing the slanting edges. So from the top view parameters, we have to draw vertical projection line until meeting the XY line. Here, the base of the object is resting in horizontal plane. So in the front view, the base will come exactly in XY line as a line. So we have to draw horizontal line representing the base. Then here the height of the pyramid is 60 mm. So to the baseline perpendicularly, we have to draw axis line. Then we have to connect slanting edges to the base. Here you have to give the name A, B, C, D by referring the top view parameters. Then this is the O dash. So we have to draw OA, OB, OC, OD for representing the front view slanting edges. OA, OB, OC, then OD. So here, based on the given problem, during the front view, three slanting edges are visible to the observer. The remaining one slanting edge is invisible. If it is invisible, that parameter has to be represented by dashed lines. So whatever the visible slanting edges, that is represented by continuous. So before sectioning, we have drawn top and front views. Now we are going to do the sectioning. So here the cutting plane, there is a section plane that is perpendicular to VP, inclined to HP. And also the cutting plane meeting the axis at a distance of 25 mm from the apex. So here the axis inclined to HP means we have to represent that parameters on front view. So first we have to mark a cutting plane meeting point on the axis from the apex to the O dash is the apex point. On the axis line from the 25 mm below, we have to mark a point, draw an horizontal line, place the pro circle center point here, and a mark angle 40 degree, and draw a cutting plane line. So once we have drawn the cutting plane, you have to give numbering on the slanting edges because the cutting plane meets all the slanting edges. Due to sectioning, we are getting new corners. How many new corners? Four new corners. We have to give the name as 1, 2, 3, 4. There is 1 dash, 2 dash, 3 dash, 4 dash. Then you have to differentiate the line thickness due to sectioning. After sectioning, this square pyramid become two portions. The topmost small portions are removed. So remaining what shape observer will be getting is the shape observer will be getting. So below the cutting plane line, whatever the parameter is there, that has to be represented by thick lines compared to above the cutting plane parameters. We are assuming that above the cutting plane, small portion is there that is removed. So that won't be visible during the front view after section. So now this is section at front view. The next is section at top view. So for section at top, after sectioning, you are seeing from the top of the object. When you see from the top, bottom base is visible. Along with that, the sectioned portion also visible in the top view. So that also we have to represent in the top view. How to represent that? We have got new corners on the slanting edges 1, 2, 3, 4. From there, we have to draw vertical projection line until meeting the corresponding slanting edges in the top view. Let's say, for example, 1 dash which is on OA slanting edge. So from 1 dash, we have to draw vertical projection line until meeting top view OA slanting edge. And then meet as 1. Similarly, we have to draw vertical projection line from 2 dash, 3 dash, 4 dash. Mark that intersecting points, meeting points on respective slanting edges. Then you connect all those corners 1, 2, 3, 4. So within that area, that is representing the sectioned portion in the top view. So if it is sectioned portion, that has to be represented by hatching lines. Generally, hatching lines are represented by thin lines by keeping 2 to 3 mm space between lines at 45 degree inclinations. After sectioning, below the sectioned, there is a A1, B2, C3, D4. These are all the slanting edge portion left. So that portion only we have to represent by dark lines. The remaining parameters are removed. So we have to represent remaining parameters by thin lines. So now this is section at top now. The next we have to draw true shape of the section. How to draw the true shape of the section? When we section a square pyramid, due to sectioning, we are getting some new surface on the solid object that has some shape. That shape is called the true shape of the section. So that has to be represented separately. So for that, to this cutting plane line parallelly, we have to draw another reference line, name it is x1, y1. Then from the cutting plane parameters 1, 2, 3, 4, cutting plane line parameters 1, 2, 3, 4, we have to draw a line perpendicular to the new reference line x1, y1. Then measure the distance using compass, measure the distance between XY line and top view corners 1, 2, 3, 4. Reproduce the distance of this for this new reference line as the central point. Make a mark on the corresponding projection line. Then finally connect the all the four corners. Then represent those parameters, those areas by hatching lines. So now this is acting as a true shape of the section. Due to sectioning, we are getting some shape, sectional surface on the square pyramid. The shape will be like this. So now this is a sectional front view. This one is a sectional top view. This is a true shape of the section.